Hello everyone, this is PCB, your trusted PCB partner. Today, we will introduce how to use the keep-out layer in KiCad. The keep-out layer refers to the area around physical components required for assembly or other functions where no other components should be placed. If the distance between components is too small, assembly may become difficult or even impossible. When discussing assembly, the required area depends on the assembly method, whether it is automated or manual installation, as well as other possible details. There is no absolutely correct area shape or keep-out layer size that can guarantee trouble-free assembly, while also being the optimal size for dense placement. A compromise must be made between ease of assembly and keeping the assembly area as small as possible. As a rough guideline, KiCad can check whether components are too close by examining keep-out layer collisions, that is, by checking for overlapping keep-out areas. So, let's take a look at what this layer is used for. Let's reposition a component we previously drew, one that doesn't include a keep-out layer. We'll delete these first. This one has a keep-out area. So, what effect will this have? If this layer is not present, let's place it somewhere first. As you can see, when we try to move it close to this resistor, it doesn't give an error. So there won't be any errors during placement. Of course, if you run a DRC check, it will report an error. Now let's take a look at its effect. If you install it like this, although no error is reported, the physical structure already occupies the space of this component, which will prevent the resistor from being installed. Or for components like this, if you're using an automatic pick-and-place machine for soldering, it might be possible to solder them. But if you're soldering by hand, then with them this close together, the component leads can't be soldered. So let's see what effect it has if I add this layer. First, delete this component, then we'll modify our footprint. Here, select the layer since our component is on the top layer. We'll choose the F, fab layer. Then I'll directly place a rectangular area for it. I'll display it. Draw a region like this, and then go back to the PCB to place the same component again. Now, when I move it, you'll see that as it gets close, the component turns red. This way, it's easy for us to spot problems during layout. It ensures that the spacing in our layout is reliable. However, this spacing also depends on your assembly method. If you're using machine assembly for everything, then the spacing can be made smaller. But if you're soldering by hand, you need to take this into account, especially with taller components. If the tall components are soldered first, it becomes very difficult to hand solder the shorter ones. So the main goal is to ensure that you can spot these interference issues during the layout stage. Next, let's look at the adjustable area layer, which must be a closed shape. This shape should be graphically drawn on either the F adjustable or B adjustable layer. And it must be exactly the same as the cut layer and the board outline layer. Each line must end where the next line begins and it cannot intersect. The last line must end at the starting point of the first line. Apart from this closed shape, there should be nothing else in the package on this layer. What does this mean? It actually means the same as the board outline layer, the adjustable layer you draw must be closed. Just now, I drew a rectangle, which is a closed shape. If we don't use a rectangle, for example, if we use lines to draw after selecting the layer, we start drawing lines. For instance, let me intentionally draw an open shape to see what happens. We still place the component here, and when we place this component, we can see that it is not closed. To make the DRC check only show this error, we need to press B to relayout, so that the pad is exposed, the gap around the pad is exposed to prevent this error from being reported. Then we perform a DRC check to see what happens. At this point, it will report an error saying that our adjustable layer is not closed. So when we draw the adjustable layer, we need to pay attention that it must be a closed area. In actual use, especially during automated assembly, components can be placed quite densely. For example, for 0402 or 0603 components, as long as the copper spacing or impedance spacing requirements are met, there's no need to draw an adjustable layer because they are already designed to accommodate high density installation. Similarly, this also applies to some connectors. When soldering certain connectors, we may need to assemble several of them together. In such cases, you should manually delete the adjustable layer during the design process, or simply avoid drawing the adjustable layer in the first place to prevent errors during layout. Alright, that's all for today's content. If you enjoyed this video, please subscribe to my channel for more content. Thank you everyone.